Good afternoon, students. So this afternoon I would like to finish the problem number 2 on the airplane and diver worksheet that you have loaded on your Canvas account in the files section. So let me read the problem to you. I will underline important information. Then we're going to generate a column of knowns and unknowns and draw a picture to help us solve the problem. So let's go ahead and get started. A 68.85 kilogram diver jumps off of a 12.25 meter tower. Calculate the diver's velocity when she hits the water. The diver comes to a stop 3.65 meters below the surface of the water. Calculate the net force exerted by the water. So what I want to do is go ahead and draw a diagram. So we have a diver jumping off of a tower. We'll say this is the steps here. Okay, so the diver, she is going to jump off of the tower. And her initial velocity in the y direction is 0. So I'll say initial velocity in the y direction right here is 0 meters per second. We know that she is 12.25 meters above the surface of the water. So what we want to do is first calculate the velocity in the y direction when she hits the water. And I'm going to use a subscript of HW to indicate her velocity when she hits the water. Now, after she hits the water, she comes to a rest 3.65 meters below the surface of the water. So we need to include that, 3.65 meters. And we know that her velocity here is 0 meters per second. And we know it's 0 meters per second because the problem tells us that she comes to a stop. Okay? So we know that the acceleration due to gravity, so I need to generate a column of knowns and unknowns. So G is negative 9.8 meters per second squared. Okay, initial velocity is 0. And we want to calculate the velocity in the y direction when she hits the water. We don't know this yet. We're going to calculate this, but we know that the units are going to be in meters per second. Okay, so let's solve this half of the problem first. What we want to do is use the base equation, final velocity squared equals initial velocity squared plus 2 times acceleration multiplied by the object's displacement. Now, what I want to do is adapt this equation to our situation. Okay, so final velocity. So I've indicated down here, this is the velocity in the y direction when she hits the water. This is going to be squared. Now, you already know that the initial velocity in the y direction is 0 meters per second. So we don't need to rewrite this because that goes to 0. Now we have 2 multiplied by the object's acceleration. Now we know that the diver is going to experience the acceleration due to gravity, so negative 9.8 meters per second squared. And our displacement is going to be a negative 12.25 meters. Remember, there is a difference between distance and displacement. Displacement is a vector, so we are required to show direction. And so the negative sign will indicate a negative y direction. So negative 12.25 meters. Okay? So velocity in the y direction when she hits the water squared. Let's go ahead and get out your calculator. So we've got 2 times negative 9.8 is going to be negative 19.6 times negative 12.25. I get 240.1. Now let's take a look at the units. I have meters per second squared times meters. And we know a meter times a meter is meters squared. So we're going to have units of meters squared per second squared. Now we're not done here because we have a squared value on velocity in the y direction when the diver hits the water. So we're going to take the square root of both sides of the equal sign to eliminate our square here. Okay, so let's take the square root of this value. So the velocity in the y direction when the diver hits the water is equal to 15.495. Now, not only are we taking the square root of the numerical value, we are also taking the square root of the unit value. So the square root of meters squared per second squared is going to be meters per second. Now remember that this is the velocity, and velocity is a vector, so we must describe the direction of velocity. And so when she jumps off of this small tower, she's headed in a negative y direction. So her velocity is negative. So you can draw a vector arrow, or you can write down, or you can simply add a negative sign here to indicate a negative y direction. So that is one of our answers. Next, we need to calculate the net force applied by the water. So she is traveling in a negative y direction when she hits the water, but the water is going to apply a force in the positive y direction to bring her to a stop. Okay? So what I want to do is I'm going to draw the second half of this problem. I'm going to draw a diagram over here. So this is when she hits the water. I'll draw the water right there. So this is velocity, y direction. When she hits the water, a negative, and I'm just transferring this value that we calculated, 15.495 meters per second. We know her final velocity, d sub f, in the y direction is 0 meters per second because she comes to a stop. And this takes, she travels a distance of 3.65 meters. Okay, so what we're going to do is we are going to start off with the same base equation that we originally started off with right here. So I have final velocity squared equals initial velocity squared plus 2 times the acceleration multiplied by the object's displacement. Now, what we're going to do is end up using Newton's second law of motion. So we know that the acceleration of an object is equal to the net force applied to the object and inversely proportional to the object's mass. What I want to do is solve for net force, and how we're going to do that is multiply by mass on both sides of the equal sign. So when we do that, mass on the right-hand side cancels out, and this is going to leave us with net force applied to the object is equal to the product of the object's mass and the object's acceleration. Okay, this is the equation that we are going to use after we solve for the object's acceleration. And we're going to use this equation to do that. So what I'm going to do is subtract the initial velocity squared from both sides of the equal sign. So this is going to give me final velocity squared minus initial velocity squared is equal to 2 times the acceleration multiplied by the object's displacement. Now what I want to do is divide by 2 and displacement on both sides of the equal sign. This will give me acceleration is equal to final velocity squared minus initial velocity squared divided by 2 times the displacement of the object, okay? So the final velocity squared right here, we already know it's 0 meters per second. Boom. This guy goes to 0. We don't need to mess with it anymore. So in my numerator, I have minus, and we need to utilize our parentheses here because we have, by the equation, we have to keep this minus sign there. So minus, open parentheses, my initial velocity is the velocity that the diver hit the water. So negative 15.495 meters per second. And we have to square that, divided by 2 times the object's displacement. Now right here, we start here, and the object is still moving in a negative y direction. And displacement is a vector, so we have to show direction by including a negative sign. So negative 3.65. And we have units of meters. Right here, we need to go ahead and square this value. So negative 15.495 meters per second. We have to square that. We get 240.1 meters squared per second squared. But then I have to apply my negative sign there. So we have a negative 240.1 meters squared per second squared divided by 2 times 3.65. So a negative 7.3. And we have units of meters. We will divide here, and our acceleration is 32.876. And this is meters, or algebraically we can write it as meters over 1. So one of our meters will cancel, leaving us with units of meters per second squared. And this is positive. So remember, acceleration is a vector and it's showing direction. So the acceleration is in the positive y direction, which coincidentally is the opposite direction of her initial velocity. So when she hits the water, since her initial velocity vector and acceleration vector are pointing in opposite directions, she's going to slow down and stop, okay? So we need to use this value for acceleration. I want to come back to this Newton's second law here. So net force is equal to the product of the object's mass and acceleration. And I'm running out of room here, so I'm going to go ahead and erase the diagram. So, and this is the net force applied by the water. The mass of our diver is 68.85 kilograms. And the acceleration that the diver experiences is a positive 32.876 meters per second squared. So the net force applied by the water is equal to 2,263.6. And let's take a look at the units here. We have a kilogram times a meter per second squared. We know this to be in Newton. And remember, force is a vector, so our net force is positive, so it's being applied in a positive y direction. So our vector for net force is pointing in a positive y direction. Okay? So if you have any questions over this problem, just call me or send me an email or send me a question over Canvas, and I will be more than happy to help you out. I hope you have a wonderful day.